All right, so here's my square. It's a unit square. It's 1 by 1. And then currently right now, where would I say the square, if I had to give you, say a single x value of where the square is located, what would you say that value is?
2.
Okay, you could say it's 2. Uh, in that case, you're looking at the left edge as the reference. Okay. Um, I guess it's also valid to say that it's 3. But in general, we will find it most useful to assign the coordinate, like a single coordinate, to the center of an object. Right? If I want to put this square in the middle of my screen, I would like to set its x coordinate, assuming the middle of the screen is, you know, 0, for example. I'd be, if I set x equal to 0, bam, it's in the middle of the screen. It's not offset, you know, on the left edge. So what is the center of this shape in x?
It's 2.5.
2.5. Awesome. How did you get that? That was so fast. Like mathematically, what operation did you do to figure that out?
Visualization.
Visualization. Perfect. So MATLAB's not going to have the intuition, the quick insight that you have. We're going to have to do this mathematically. Imagine these are your grades, right? It's not 3 and 2. It's you got 100 on the first test and a 90 on the second test. What's the middle, the center of your grade? What's your effective grade in the end?
Add them together, divided by 2. I think.
Yeah, 95. We'll call that the mean, right? Or the average. The mean is because that's the technical term in MATLAB. But we want to find the center mass. If the shape is symmetric, if each point, if the points are distributed equally, then the center x will be the average x value. Let's look at that. Let's make sure that makes sense. This is the x data here is there are 4 x data values in this array. What are they?
2, 2, 3, 3.
Okay, yeah, if you're going around clockwise, right? And what is the average of 2 plus 2 plus 3 plus 3 divided by 4? Well, that is the average. That's the definition of the average, but
2.5.
yeah, so that's set. What 4 plus 6? That's 10 divided by 4 is 2.5. Great. What if my shape was a little bit more sophisticated and had a dot here and it was kind of like a house? Would this trick still work? What new value did I add to my x data?
2.5.
Yeah, and that won't change my average. Okay. Now that this is going to give us a rough center of the object. If we were going to do the same in y data, the average y is going to be somewhere closer to 3 than it is to 2 because of this higher point, right? And that's just going to be, we're going to call that the center of the object. All right? So if that's the center of the object, then when I say move x2, what I really mean is take the center of the object, the 2.5, and move this thing so that its new center is at 0. Okay? Which would mean in my rough graph here that the new object sits roughly here. And so what are the new coordinates for my x's? If this box is 1 wide and now the average x is 0, what are the coordinates right here?
That's 1, 1, and then -1, -1. Like
Hmm.
0.5.
0.5.
5
Oh
and
wait,
negative
wait,
0.5.
they're all.
Right? It's 0.5. The new x data, negative 0.5. Do we see that? Now, yeah, I messed up my my scales here. It does look like it's at 1, 1, but it's not. It's a trick of optics. So what's the math that I did to take x data and convert it to new x data? What did I do? I subtracted something off these values. What did I subtract? What's the math problem? It's
2.5.
2 minus x equals negative 0.5. Right? So x is 2.5. Right? Just some algebra there. That number should be familiar to us. What is 2.5?
That was the average we just got.
It's the average. Yeah, yeah. And in fact, we can think of all these objects as sitting at the origin, right? And they just have, if they're not at the origin, they're just offset by some constant, their center of mass, right? Their average is pushed. And if we take that push off of the average, then the new average of this array, what is the average of negative 0.5, negative 0.5, 0.5, and 0.5? What is this average?
0.
Yeah, if I take the sum of these x's, that's going to be 0. And then divide by 4, that's also 0. Okay? What do we think? I can take any shape. You give me a shape in space. I can snap it to the origin by subtracting the mean off of all its values. Okay? I can do that. That's what this does. Once it's at the origin, once its center of mass is 0, then I can put it anywhere I want in space by simply adding that back to all of the x data. So like, here we go. Let me make this more concrete. This is the shape now. This orange shape is where we started our life. And I said move x to negative 3. That's what I want. I want to take this cool little house and I want to put it way over here. I don't want to change the y's. I just want to shift this thing over to negative 3. Yeah? Now you could figure out what you need to subtract to get this house over here, but that's going to be, so you could say move x by, and that would be negative 5.5. But if my intent is just to get wherever your house is, I don't even know where your house is, put it at negative 3. Okay? The most direct way to do that is actually going to be a two-step process. The first step is going to be to move that house back to the origin. And here I'm confusing the picture because I put the y data to the origin as well. Let me make sure that doesn't confuse us too much. Step 1 is to remove any existing offsets in x by putting it at the origin. Okay, so that's step 1. Oh, you silly thing. You think I drew a pentagon. I drew a home. And then step 2 is going to be apply a new offset to our new location. So let's go back to code now, and we'll try by looking at both the code and this kind of graph here, see if it can make sense. So give yourself a new function, and we're going to call it move. Move x2 And if you like me and messed up and you called it untitled, you make sure to change the function here. Okay. Same as move x by. There's going to be no output. We're going to have the object. And then rather than an offset, I'll just call this location. Because that's really what it is, right? It's not an offset anymore. It's an actual spot that I want it. Okay? So this is going to be a two-step process. You see, we're moving it to the origin, and once it's at the origin, then we know the offset. The offset is go to the location. We remove that unknown variability of the object by snapping it to the center, and then we can simply add location onto the x data, and that will put it where we want it. Okay? So, how do we move the object to the origin? We want to do something to the x data. And what is
Set
that?
it equal to 0.
Set it equal to 0?
Yeah.
Well, why not? Let's see. There's some skepticism, but that's fine. Let's leave it for now. Who haven't heard? Riley. What's step 2? Oh, I can't quite hear you. Tricky. All right, how about Peter?
So I would change, or I would make the location of the X data. Wouldn't you just make it 0 to get it to the origin?
Okay, that's step 1, and I don't know that this is quite correct, but we're going to leave it for now. I'm looking at step 2 here. Do I know how to do this? Apply an offset to an object? Do I have a function that does this?
You would add the X value you want to the X data.
Yeah. So you could do one of two things. You could do exactly that, or you could say, oh, I have a function that does this for me. Right? A function can call another function. Okay, so I think line 6 is correct, but line 4 is making me nervous. But maybe it's not making you nervous. Let's see why I'm nervous. Let's play the game. Here, I want to say, I've called this move x2. That's unfortunate. We don't have a move x2 thing yet, but why don't we just go ahead and change this x by to move x2. I think that when it falls off the screen, the rock should go to location 6. Fine. So all's well. Get excited. Location 6, go! Not good. I have destroyed my rocks. What is X data? Let me pause here at this line. We'll put a breakpoint.
It all became 0.
It did. We sent it to a black hole. Right? Let me just make sure that's clear. Can you see the bottom of my screen here? Ah, there we go. What is rock.xdata? Oh, it's this clever list of points that I can't remember who gave that to me, but maybe it was Andrew. The triangle that he created so lovingly. And what are we going to do the moment, well, let's say step, now you see these step tools here? Step in. That means dive into the move x2 function. Let's go there. Let's hit step in. Bam, here we go. Uh-oh, what's going to happen? Oh no! Crushing, right? And it doesn't even make sense how it's been crushed. Like, we had 3 points, we have 3 y data points, we have 1 x data point. The whole thing is a mess. We don't want to set x data equal to 0. We want the average of x data to be 0. You see the difference? We want the average x data to be 0. And how do we make that happen? We did that on the, that's what we showed on the whiteboard here.
We have to use the mean function.
Yeah, so we want to say, well, if we want the average to be 0, we need to subtract off the average. I mean, it's kind of circular, but let's see how that works. And now let me step and look at rock.xdata. Oh, did we kill it? Oh, no. Oh, well, object.xdata. Oh, we can't change the function while it's running. But next time through, we'll be okay. Oh, stop it. Go to game.m here. Wait for it. Okay. And now we're right here. Let's step in. We'll step one more. And now let's look at object.xdata. Look at that. The average of negative 0.5, 0, and 0.5 is 0. Now when I move it, move x by, what that function is doing for me, let's step into that. Step in. Okay. Look, I'm applying this new offset. So now object.xdata is all those other, the previous values plus 6. And so what is the new average? What is the average of 5.5, 6, and 6.5? 6. And so the center of the object is now located at 6, which is my original goal, because I called move x2 6. See how that two-step process works? We subtract off the existing average, and we give it a new average. What are our thoughts? This is probably our hardest function, as far as conceptually. It's not a lot of code there, but it's a thinker. All right, give me a move y2. So do the same thing, move y2. All right, so we're going to say new function, move y2, and then we'll just simply go up here. Right, we're just going to replace all the x's with y's. All right, And now we can go and do another refactoring where we, rather than move y by, we can say move y2. And then if we put it at 15, we'll see it kind of pop in all of a sudden. Let me show you what that looks like. It's better to put it above 15 so that it doesn't snap in quite so abruptly. So we can move it up to like 18, and that way it'll come in nice and smooth. Okay. All right. Now I think things are looking good, but I'm a little bugged that these rocks just step. What I really want is to give each rock a new random horizontal offset, right? A new random x location. When they fall off the bottom of the screen, I want to move y to the top, and then I want to move x to some random location. Not move x by. I want to move x to, for example, 1 or 14 or 10. You see? See that move x to 6? Why not replace 6 with a random value between 0 and 15? And we already had a hint on how to do that. And by hint, I mean I just said how to do it, I guess, but it was hintish. So what can I replace 6 with in order to get a value between 0 and 15? Now the reason I'm saying 0 to 15 is because that's my viewport. That's my playing area. Amanda, what do you think?
Part about making 6 0, or just a range of numbers?
I want it to be different each time. Right now, it's sort of sad. They just always go to 6. And I'd like them to...
Could it just be Randy, or...
Let's not do Randy. You guys said Randy. Randi. Let's not use Randi. Randi is a source of much confusion. And anyway, my space where we're in outer space, is not discretized into integers, right? I want to be at 5.3 or 7.6, right? I want to be anywhere in between 0 to 15. So rand is going to be valued 0 to 1. I want to value 0 to 15. What should I do?
Just do rand and then times 15.
Yeah, perfect, right? Think of rand not as a number between 0 and 1, but as a percentage. Right? And if you think of it that way, you can scale a percentage, right? What's 20% of, some crazy number, and then you can get either 100% of that number in some, lucky scenario, or 0% of that number in some maybe unlucky scenario, but most likely you get somewhere in between. And so you get somewhere between 0 and 15. Right? So rand times 15. There we go. I was waiting for one to be off to another area. But now we're starting to get the impression that there are maybe multiple rocks, more than just 2. Okay?
Sir, could I see your move X to a tab real quick?
Mm-hmm.
Okay, thank you.
Mm-hmm.
So what's the point of putting parentheses after rand if you don't put anything in it?
MATLAB is like your, casual uncle who you shouldn't eat candy, but he's gonna let you do it anyway. When you call a function, you should always put parentheses after it. And if you're not passing it any information, then just leave the parentheses empty. But it indicates to someone reading your code that is a function that you're calling, and not some variable called rand that is like the number 4. Right? A function is an action that's being taken. And in every other programming language that I've ever seen, and I've seen plenty, you can't get away with putting the parentheses at the end of it. For some reason, MATLAB lets us do it, and I will strive to be consistent and always put parentheses after my rands or any other function that I call. And even though MATLAB doesn't necessarily require you to do it. Does that answer your question? Right.
Yes,
Whereas,
sir, thank you.
yeah. So like other things like rock are just variables, and we call them, and we just say rock. Okay. And I shouldn't say uncle. That's or your aunt. Either could spoil you. And in fact do for my kids. But okay. Now I'm getting greedy here. I think what I really need is a lot more asteroids. Right? And I'm not saying rock 3, and I'm not saying I want rock 4, right? I'm tired of this up here. I don't want to have to copy and paste that 15 times. Right? I like the shape of a triangle. I like the shape of a square, and I think all my asteroids should be either a triangle or a square. Right? That's enough for me. I'd like 5 of each, say. 5 triangles, 5 squares. And that'll be a nice hazardous field to navigate. All right? So if my goal is to fill up this rocks array, and I said I want 5 of each, right? Can you give me 2 for loops that at the end, rocks will have 10 elements in it? 5 of which will be squares, and 5 of which will be triangles. And yeah, they'll all be on top of each other. But that won't matter because I've got the move x2 and the move y2 functions, so I'll then use code to separate them all out and put them across the top of the screen. So give yourself a minute here and see if you can write a couple for loops here to populate rocks with 10 items. How are we doing? Let's see, Ben Curry, what are you thinking so far?
So what I was kind of thinking was, so there's like an overall for loop that goes 1 to 10, like it creates a matrix.
Mm-hmm.
Just like we had our rocks one earlier that had 2 things in it. This one had 10 in it.
Mm-hmm.
And then inside, I was thinking that we could do 2 for loops. So one for 1 through 5, and then another one for 5 through 10. And so the first one does like a random generator for squares, and the second one does the random generator for triangles.
Okay, yeah, I like. I think that second part you said there these 2 for loops, one that goes through the first 5, and then another goes through the second 5. Let's try that structure. So 4, and then I equals 1 through 5. I just want to go through 5 things. I want to and then I want to do it again right? And rocks is initially going to be empty. But I want to set rocks, the ith value, equal to something. So if it's going to be a square rock, which line of code should I copy to put it at line 10?
The one with 10, 11, 11, 10 for the X value.
Right? And what about the triangle rocks?
Just copy rocks 2.
Mm-hmm. You see, so nowhere am I actually creating a rock 1 and a rock 2 anymore. The minute I create them, I put them into this array. And by starting this array from 1 to 5, I is 1, then I is 2, then I is 3, then I is 4, then I is 5. They go here. Then and then the next one, I is 6, 7, 8, 9, and 10. And that way they don't overlap with each other. Okay? Now, if I were to play my game at this point, now what's great? What did I not have to change anything in? The rest of my game. I just have 5 times as many rocks as I used to. I used to have 2 rocks, now I have 10. Did I do anything in my actual game here? No. Oh, that's a good smell. Right? That feels right. The physics engine here doesn't care whether there's 1 rock or 1,000 rocks. It just goes through all the rocks. Okay? That's good. Now up here, I'll leave it to you if you want to make your rocks clever looking, like a dark gray or a brown, or set the edge color to something, right? You can play with it. Any of the graphics pieces you can tweak up here. Fine. I think they're a wonderful color right now. So I'm not going to mess with them, but you certainly can. What I don't like is the fact that they're all on top of each other. Oh, what happened here? Let's, oh, rock 1. Where are we? Line 24. Oh. We do have a small problem here. Sorry, I forgot we hadn't fixed this part yet. Here we're dropping the rocks. Let's fix this. How can I change this to a for loop? Let's see, Ben Watson. Right now, line 25 and 26, I'd have to have 10 of those lines now because I have 10 different rocks. How can I make this a for loop?
You could do I equals array of 1 to 10, and then you could replace the 1 and the 2 and rock 1 and 2 with I. And then end it.
Mm-hmm. You can, yeah. Definitely. But if I then come back and tell you I want 100 rocks, you're going to have to come back to this line of code and remember to change 10 to 100. So is there a way I can write the for loop maybe like line 28 where I don't actually care how many rocks are in the array?
You could do length rocks.
I could. Yeah, so we could make it work. But look at line 28. Do you see how we wrote that for loop? Right, you know, get out of the mindset that the for loop has to work on numbers. The for loop works on things. If those things are numbers, fine. It's 1 and then a 2 and then a 3 and then a 4. If that thing is a bunch of rocks, then it's the first rock and the second rock and the third rock and the fourth rock. Right? So we can just say for rock equals rocks. and then we can say move y by rock. And now we'll lose the ability to make them go different speeds, but maybe we'll come back and put that capability back in later. Okay? All right, I think we will end up coming back and using the linked rocks and doing something else there so we get different speeds, but let's just leave that as it is for now. If I could not mess this up. Move right by. What do we do here? Something evil. Pop in here. All right, so where are we? Rocks. Oh no, what happened here? That's not good at all. Rocks. I equals 6 to 10. Did we not get the result of this that we want? Let me pause here. One moment. So I hope they didn't change how this works. Oh, that's a fill object. All right. Step. One moment. Oh, silly MATLAB. All right, let's put a pin in this up here. Let me comment that out. And let's give me a minute. I'll look at the syntax for handling arrays of objects here. But we can just do this as well. Here we go. All right. So this will put us back. And let me make sure this still works. Yeah. So we had great hopes up there. I think the 2020 syntax might have changed for me being able to fill up rocks. The issue is MATLAB is very optimized to be handling arrays of numbers. We're handling arrays of something called patch objects here, and there's some complexities to that which we don't really need to worry about. But for what we can just go ahead and create our array explicitly without for loops here. So if we wanted more rocks, we could just make this thing longer. And then yes, it looks horrible to me as well as you, but you know, one can do this. All right, so here we've got 4 rocks now rather than 2. Okay.
So what does your rocks array look like? The one that defines what rocks is equal to?
Well, that's what I'm showing you here. I changed this around. We did use a for loop for it, which I think is very clever and is the right thing to do in all other languages, but
Thank you, sir.
they have an
I
issue.
got you now. I was
Yeah,
just
so
trying
we're
to
just
see
putting the
what was going
fill
on.
all in one thing here. Right, so it's like 4 fill commands rather than using a for loop. And it pains me to show you this, but sometimes our best intentions, cannot be fulfilled. All right, so there we go. Those are the rocks. And after they leave the screen, they are in different locations. But when they begin their life, they're actually all on top of each other. If we say quit debugging, you see when we run this thing the first time, that square is in the middle of the field. The triangles are all, on top of each other. This is not good. Right? So there we go. I defined the geometry of these polygons. And in fact, you did, right? Before we ever even talked about this being a game. And they're all over the place. It was just a coincidence that they looked a bit asteroidish, and that's how our whole, class is taking a turn. But let's be in control now and say, yeah, those points in space were just randomly picked. Let me move all the rocks into the right spots. Right? So where do I want my rocks to begin? I want them to all be at the top of the screen, right? Maybe off the screen a little bit, maybe at 18. So I want to move Y2, 18, and then I want to move X2, random offsets. Right? So that's going to be a for loop. And there should be a move X2 and a move Y2 command here, and see if you can figure that out. If I want them all at the top of the screen, it's going to be exactly the same 2 lines of code that I put in the if statement in that while one loop. When they go off the screen, it's the same idea. Okay? So I want to move the rocks to the top of the screen. And we can keep them changing colors randomly or not, but... Right? So now when I start my game, now they come down. Now that's an interesting random assortment there, I have to say. But... Right? So for loops are your friend. The moral of this kind of mini module here is for loops are how we deal with objects in this game. The minute you have 500 variables, each named after a different bad guy, that's when you need to rethink your process. Okay? All right, so I think we're doing pretty well. I think there's a few things I'd like to control. I'd like for them to all fall at random speeds, so each rock has its own speed. And then I'd like for them after they fall off the screen, maybe the next rock that comes down is actually going to be a little bit faster. Right? So we get this idea of increasing difficulty. Right? So we've really ignored physics so far. I mean, I had that little brief kind of tangent last time about velocity and how it's related to time. But we really need to go back into that and think about it a little bit harder, because the whole bit, our game is only fun in the sense that it has these knobs we can tweak and control things like rock speed. That's what I think of, right? I don't think of negative 0.2. Is that particularly fast or is that particularly slow? Because that's inextricably tied to the pause. If I make the pause small here, look at that. If I want to dial up my frame rate and I say, let's go make it super smooth because this looks really chunky. Watch this, right? If I change my pause to 0.01, right now I think my Asteroids game looks playable, right? All of a sudden, by making what I thought would be just a cool way to make the animation smooth, I have caused the game to go incredibly quick. right? I want my knobs to be decoupled in the sense that I should be able to twist the frame rate knob independently of like the game dynamics. Do you understand the problem? This pause thing is the speed of my flipbook. The faster I flip my pages in my flipbook, the smoother I can make my animations. But it will only make sense if the objects and the way I move them, right, is consistent regardless of the flip rate. All right, so to be more specific, if I flip 10 pages per second, all right, the delta that I move in each one of those pages is going to be much smaller than if I'm only flipping 2 pages a second, right? If I'm flipping 2 pages a second, one page I'm here, the next page I'm here, right? If I'm actually flipping 10, then I actually have 10 little, smaller animations. So the faster I flip the book, the smaller the delta should be in each frame. And that's what the problem is here. The delta has stayed the same, has stayed 0.2. So each flip of the page, I'm moving 0.2 down, and I'm just flipping it much, much faster, yeah? Does this make sense? Right? So move y by, let's think the units of this is in meters. Right? It's move y by 0.2 meters. But what I'm thinking in my head when I make my game is that a rock has a speed, a velocity. Okay? It's a meters per second. That's what's fixed. I want to think about the meters per second, and that's what you say the same. And then the actual meters that it falls is a product of the frame rate times the velocity, because the frame rate's a time, a second. Okay? And then the velocity is meters per second. When I multiply these two together, I get meters. Okay? So this is 0.01 seconds. So let's call it what it is. Let's say dt, delta time. How much time do I wait between frames? So let's call it dt. And at the top of our program, we'll have some knobs that we can tweak. dt equals 0.1. Okay? And this is going to be our time will be discretized into 0.1 second chunks. And so this is 0.1 is a units of seconds. We can agree on that because it's pause and you put in number of seconds. So dt is a seconds value. Okay? Now, I can come over here and say my rock speed I think should be 0.2. Just a guess. I might have to update this. But let's just guess that they should fall at 0.2 meters per second. Okay? That's a knob. We'll tweak it. So then in move y by, move y by shouldn't be a number here. It should be the product of rock speed, which is in meters per second, times seconds dt. Okay? And that's going to give us meters again. Meters per second times seconds is in meters. So now I run my game.
What's the value of dt again? Sorry.
Oh, I just 0.1. Mm-hmm. Okay. And now I realize how foolish 0.2 makes no sense. Let's think about if it's 15 to 0, how many seconds do you think a rock should take to transit the screen for a fun game? Maybe 2 seconds for the beginner level? Right? So if it needs to go 15 units in 2 seconds, and this is how we'll find these numbers out, right? If it needs to go 15 units in 2 seconds, how far should it go in 1 second?
7.5.
Yeah, so why don't we set rock speed to 7.5? Okay? And oh, by the way, the other problem here is that it should be falling down rather than going up. Okay? And now when I sit here and go, ooh, those frames look chunky. Right? People think my flipbook is kind of chunky. What I can do is change DT. Let's put it back at 0.01 here. And I think this is still a little fast. Now that I'm looking at it, I think it's fast. I can dial it back. 5. Right? There's an art and a science to this. Oh, smooth like butter. Right? And now I can dial DT to whatever my computer can support. Now my computer's awesome. I mean, it's amazing. The thing I'm sitting in front of just something else. Yours might not be able to support a frame rate of, 0.001, right? Millions of frames per second, but maybe mine could, right? But our game will still look the same. Meaning the playability will be the same. The speed of these shapes won't change. And in fact, I can reason about the speed of these shapes. They mean something, right? The number 5 here means that in 1 second, a shape that was at 10 will then be at 5. Right? So we can put the idea of physics into this thing. Okay? What do we think?
What about making them fall at different speeds?
Very good question, right? So right now I have a rock speed with what, speed, just a number. If I want to give each rock a different speed, I suppose I have a rocks array. I should also have a
Rock speed array.
A rock speed array, right? And so now we'll go back, and so refactoring maybe isn't a linear process, right? Maybe one thing we did, we realized we want to change. When I go back down to here, rock and rocks, we'll actually have to tweak this a bit, but rock speeds, what should this be?
An array.
An array. And I guess I could give them all the same speed. Maybe we'll go back and make this fancier. But let's just say this is a first attempt. Okay. And when they fall, okay, I need to, rather than saying rock speed here, I need rock speeds. And I need to know which rock I'm dealing with. I need some idea of I. So now I actually have to go back and do the other kind of for loop that you all suggested, correctly so. You can tell where we're going with this. I need this idea of I, because I know this little trick here only works if you only have a single thing you're working with. If I have 2 lists and I want to move down both lists at the same time, I need an index, and that way I can, match them up. And so I think maybe Ben or somebody mentioned, right, you could say length rocks here, and that'll give us the number. So I could say for I equals 1 to length rocks. Okay, but the great thing about this now is that when a rock falls off the screen, I can update its speed. So and now we'll have to go back to the other for loop structure idea. It's going to be rocks I, and rocks I, but what I can do now with this new structure is say rock speeds I. How do I make rock speeds a little bit bigger? Somebody I haven't heard from. I don't know. Zach Tiang. Zach. So we're at line 47 here, and we want to make rock speeds a little bit, because it just fell off the bottom of the screen. So the new, quote, new rock that's going to come down is going to have a new color, and it's also going to move a bit faster. So I want to
Do rock speeds I times dt.
Okay, so as you were saying, multiply by the time. So then I get a meters. Now think about the units here. This is a meters per second, and this times a second. Now this is a meters, and I'm storing it back in here. So that's not quite the point here. It's actually simpler than you're maybe imagining. I just want to make the number bigger by something. I mean, it can be up to you. It's
rock speeds I times just rand, or like 5.
Yeah, I mean, you could just say +1, right? If you want to make it a percentage, you could say times rand +1, and that would be, you know, some value between the same speed or twice as fast. You can make things fancier, right? But let's just keep it simple for now. Make it go a little faster. What do we think?
For some reason, mine won't compile or won't like work.
All right.
I get an error message at a bunch of places.
Oh no! All right. Well, let's see. We have been changing our code with abandon here, so we might have to go back and make sure everyone's still on the same page. I don't think it's getting fast enough, quickly enough, right?
Sir?
Yeah.
In my command window, this has happened before. I don't know how to like fix it. The two little greater than signs that are like supposed to be right next to the FX aren't there, and it won't let me like type in commands.
Yeah. So if you like mine right now, mine says the same thing, right? The 2 carets aren't there.
Yes.
Right. That means my game's running. So you want to go back up to the editor view here, say pause, and then quit debugging.
Okay, thank you.
Mm-hmm.
Sir, can you go to the move y by function?
Mm-hmm.
Mine is an error, and I don't know.
It is mine. It says the main doesn't work.
So the move y by is unlikely to have broken for some reason. It's much more likely that the thing you passed move y by actually isn't an object and doesn't have y data. It's like a number, like you give it 6, and you're like saying 6.y data, and it's like I don't know what that means. So it's much more likely that there's an issue here in your rocks, in your handling of the rocks array. So we did switch back and forth between two different syntaxes here. Before we had for rock equals rocks, right? Now we're going to the idea of a index counter for our for loop. And we're starting it at 1 and going up. So everywhere you had rock singular, you should have rocks parentheses I. Okay?
I think I know exactly where you lost me was when you made rocks into an array and then made it all different kinds of rocks.
Oh, yeah. Well, I'm embarrassed about this because the for loops above were elegant and should work, and MATLAB doesn't want me to be able to make arrays like that. But so here is what we did to make all of the rocks together. And you don't need to do this. I don't think this is a significant improvement over putting them all in by hand. But do you see a change in your code versus my code up at the top here? You can share your screen. I'm happy to take a look at it.
Me?
Yeah, sure. Or if you had a problem.
Sir, do you mind if I share mine really quick?
I would love for you to share your screen. Oh, we got a couple screens going on. All right. Oh, no.
Sorry, do you want me to share mine? I don't know what's going on.
If you have a problem, go ahead and share your screen, and I'll take a look. Or if you want to talk it out, it was an open invitation, not a requirement for you to.
I'll share it then, because I'm not sure what the problem is.
Okay, and then Ben will be next.
So you can see this screen?
Yeah, I just see Zoom right now, but
Oh, jeez.
I mean, I think you just need to open up Mal. It looked like Zoom was in the foreground. Okay,
Is
sure.
it good now?
Yeah. Okay.
When I try to run it.
All right. Well, so scroll up. You see you only see a part of the red arrows there, right? All right. So now, yeah. Okay. Okay. So go ahead and scroll down in your code there and put a breakpoint at line. Line. Keep going. Everything still looks good. X2, man. Keep going. Right there, line 40. You see, that shouldn't be there anymore. Because you already created the rocks. Right? That was just left over from before. So, now go back up to the top rock equals, yeah, okay. And you're at line 53 now, so you go down to line 53. Oh, rock speed, I. So do you not call it rock speeds with an S? Like, go up, where did you define rock speed? Yeah.
Speeds.
Yeah, but you need to fill it up with values. We need to give all those rock speeds. So right now we just put them all equal to 5. So for however many rocks you have, right, it looks like you have 4 rocks in there. It should be 4 5s, 5, 5, 5. Yeah. And then line 8 is redundant. We don't need line 8. Right, you're setting rocks equal in line 10. Yeah. Now go ahead and hit run. Look at that. Now you have a very skewed aspect ratio there, so all your squares look like rectangles, but that's okay.
Okay. Thank you.
Great. Who's next?
Sir, I'm going to share mine really quick, if you don't mind.
Yeah, please.
Where can I go after?
Yeah, man, let's line it up.
All right, can you see that? All right. So I fixed the one that was the rock speeds. I was just using an S.
Yep.
But it says I have an error in move to, and then on line 44.
Sure. So okay. So let's first, since I'm looking at line 47 here, line 47 in your code, that's not doing anything, right? You're setting it equal to itself. We want to set that equal to something plus 5 or something, right?
This one right here.
Rock speeds I is equal to rock speeds I. That's kind of just a truism, right? We're saying.
Yeah, I couldn't see the other part that was under code. I think it is blocked by like your picture.
Oh, okay, sorry. So just like plus 5. We're just making it bigger, right? After it falls off the screen, the next time it falls, it should just fall faster.
All right.
Yep.
Um.
So then you can try to click run.
Can you see that?
Okay. So now I've got it in line 44 here. Right?
Yep.
Now look at line 44. You've got rock singular there. Put an S, rocks, plural.
So is that all good? I guess.
Yeah, now the other thing, you're going to want to make sure you have a hold command at the top so that it doesn't keep trying to auto set the axes. Grid on xlim, ylm plot. Oh, and you also have the, we can remove that line 4 there. Yeah, sure. All right, and line 10 is not needed because line 12 just redefines rocks. All right, now let's go down to make sure you don't have any other times when you should have used a plural rocks and you have a singular rocks, right? It looks to me like the next problem is in line 39. Okay, I think you're right. Like, go ahead and hit play. Looks good to me.
It's all good.
All right, great.
All right, thank you, sir.
Who's next?
All right, here I'm gonna. Can you see that?
I can. Okay, so all right, so let's see, line 8 there. That's not needed anymore. And go down. Yeah, rocks. So you filled this whole thing up. Sure. Okay, fine. Now look at line 25.
Oh, so I can just take that out.
Right. Let's try that again.
Play it?
Sure. I think there's going to be other errors, but let's just see what happens. All right, so how about move x by that function, go to move x by, and on line 1, we don't have outputs for this, so just remove that equal sign.
Oh, okay.
Yep. And now click back to game and click play. All right, then we have rock speed with no S. So let's make sure we put speeds.
Where's that?
So that says it's at
over here.
Mm-hmm. So this all looks good. All right, now we've got rock singular I, so on line 29. Rock I, rocks. Mm-hmm.
What happened to the other one?
So let's make sure that your move x2 is looking good. Yeah, go to the move x2. Okay, object x data minus mean, object x data, move x by, comma location. All right. And then move y2. Look at line 34. What are you moving? A singular rock.
Oh, rocks?
Rocks, parentheses I. The ith rock. Right, so these are two different ways of thinking about how to go through a loop. And I'm sorry, again, I gave you a paradigm shift halfway through the lecture. All right, and then rock. Like, just go through all of your variables there. So you see again in line 36.
Oh, they all give you rocks. Okay.
Mm-hmm. Because now we're dealing with the array of rocks rather than a singular rock. And the way we're working with it is an ith value out of rocks.
Okay.
Yeah, so that should give you... Great.
Okay. Awesome.
Yeah? Mm-hmm. Perfect.
Thank you, sir.
Yep. All right. Who's next? Anybody? Bueller? No? Everyone can get their game to play? All right, great.
Yes, sir. I have a pretty specific question, but I'll just stick around after class, I think.
Okay, sure. Oh, and someone's reached their maximum brain capacity. Fair enough. Well, good. Perfect time to top off right at the end of class and digest. This is a lot to go through. And I'm sorry about the Bill syntax snafu at the end there. I think that threw us all for a loop. But we're good. Connor's gonna relax and on that bucolic farm scene, and we'll meet again tomorrow. We'll have a short little quiz. Nothing to worry about too much. Just maybe on some of the ideas of for loops, and that'll be good. No write-up for today. Okay. Have a great afternoon. I'll see you tomorrow. If you have questions, feel free to stick around. I'm happy to talk.
Thank you, sir.
Mm-hmm.
Thank you, sir.
Tomorrow.
Peace.